Okay, everybody, we're going to get started. It turns out that the previous instructor accidentally took the microphone, so I don't have one right now. So if you can just keep the chatter down, it'll make my life a lot easier. In terms of announcements, your first homework assignment was just released right now. I don't have all the test cases ready for it, but they should be coming out over this week. You have 3 problems to work on. You currently don't know enough to do any of them in C++, but you do know enough to be able to do them in Python. So if you want to get a head start right now, what you can do is you can start those assignments in Python and see if you're able to get them to work, because theoretically you should know enough to be able to do that. And then once we do know enough in C++, you can start transferring, you're translating your Python code over to C++ code to make that work. I just posted Friday's lecture this morning, so if you're looking for that, it's there now. Any questions before we get started? I am recording. I remember that. Okay. So I believe last time we left off, we just were wrapping up about strings. I believe we covered this slide, but you can add 2 strings again to concatenate them together. You can use erase to remove elements from a string, and you can use insert to add elements to a string. Insert, remember, is very overloaded function, so there are ways of adding whole strings, substrings, characters, lots of different ways to do it, so make sure you check out those links. The next thing that you're probably interested in is I/O. So in Python, right, you use input to get your input. When you call input, how do you get your input back from Python? What does the input function return in terms of a type? String, right? Always gives you back a string, and it reads in the entire line. In C++, it's a little bit different from when you read, but there are still options for reading the entire line in as a string if you choose to do so. If you want to be able to use the I/O functions, they're in I/O stream. So cout is the thing that you'll write to print to the screen, and cin, it's okay, thank you. And cin is what you'll use to read input from the user when they type it on the keyboard. The operator that you separate the things that you're trying to read in from or read out to is this double arrow guy. So when we want to print to the screen, we say, cout, enter your age. Right? If we had multiple things that we wanted to be able to print, like we're doing down here, we want to write to cout, that's the screen. In 1 year, you will be age +1 years old. And by default, it's not going to put any white space in between the different arguments. So you have to make sure that you manually insert that white space. If you don't, everything's going to run up right next to each other. The other thing that you can see from this example is that I don't have to cast the type. Right? In the Python example, I had to cast the type to an integer so that I could add to it later on. But in C++, it knows automatically what to read from the input based on the type of the variable that you're trying to read it into. So since int is an age and we're trying to read it in from the keyboard, it's going to try to read a sequence of numbers. And then it will automatically translate those numbers into the numerical value. So if the user entered 1, 2, 3, it would go and it'd read those characters 1, 2, 3 and turn it into the number 123. If what the user has typed doesn't match, they'll fail to read, and we can check to see if that happens. So if you ask the user for their age and they enter Bob, well, we're actually not going to be able to read anything to age because Bob is a sequence of letters, right, which is not a sequence of numbers. And so the read would fail, and I'll show you in a minute how to check to see if the read did indeed fail. So the question is, if we entered in just J here, would the number be translated into its ASCII, or would that letter J be translated into its ASCII value? No, it wouldn't. We'd have a failure to read because when we're trying to read an integer from the keyboard, we're looking for a sequence of numbers, and J is not a number. Any other questions? So IO stream, again, you need that. Out is how you write to the stream. Whitespace isn't automatically added. CN will read in the input and it will parse the converted type. If you want to read an entire line, you do std : get line. You pass it in iStream. An iStream is a generalization of an input of which CN is one. So you could put std : CN right here, and you'd read that entire line into the string, and you'd be good to go. You could then parse it later on, which we'll probably get to in a little bit. Endo will put a new line character to the end of the screen when you write it out, and it will also force the screen to be updated. So whatever you've written so far will be forced to show up to the screen. So when you try to read in your basic types, if you try to read in a string, it'll attempt to read a sequence of non-white space characters. So if someone did hello space world, and you tried to read it into a string, you would just get the hello, because the space would stop you from reading. If you do a character, you'll get a single non-white space character. An int will get you a sequence of integers, and a double will get you anything that's validly formatted as a double. So some numbers, optionally followed by a decimal point, followed optionally by some more numbers. Yeah. What else would you want to use a double for? No, you would use a string if you wanted letters, right? Or a character if you were just looking for a single character.
Hello world.
So it depends on how you wanted to do it. If you wanted to read hello world as two separate elements, you could read it into two separate strings. So if I wanted to read hello world, oh, one of the students from the prior class just brought it back from the instructor. Okay. But thank you. Oops, I don't. One thing to note is when you're doing your assignments, make sure you have a separate directory for each problem. Don't put them all in the same directory. Your life won't be good then. Also make sure that when you submit, including for this current assignment, when you zip the files, make sure you're zipping the files and not the folder that includes the files. If you zip the folder and submit the folder, the submission is going to fail. You need to submit multiple files to zip the files themselves by selecting multiple files, zipping those together, and then submitting that. So let's say we wanted to read in hello world, right? There's two different ways that we could do it. We could have a pound include string, and then, you know, might say cout enter hello world, and we might have our first string hello and our second string world. Again, I'm declaring multiple ones in the same line. And so we could do std : cn into hello and then into world. We can do multiple reads at the same time. We might change this to be colon and then get rid of the new line character showing up. And so now when we could cout hello followed by a space because that won't automatically show up, followed by world. And again, this will work for like any two strings that I decide to enter. So we might, instead of entering hello world, enter Bobman, and it prints out Bobman. You know, amazing. But because we chose to read two strings, the first string will read everything up to and including Bob, but will stop because it hits this white space character here. And it won't continue reading. And then the second one, it'll pick up from where it left off in the reading, and then it will read the man portion. And then once it reaches the new line character that we typed to end the line, it'll stop reading as well. The number of spaces in there could be like arbitrarily long. So you might have like start, tab, 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 space, 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 tab, 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 space, 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 end. I get start and end, right? Because the formatted input for reading a string will know to skip all that leading white space for you. So you don't have to parse it. If you wanted to get an entire line, we could do something like cout, enter a line of text, and then std : get line. And then we want to read from cin, and we want to read it into line. And then cout, you entered line. Followed by a line. We probably also want to put a new line here so that it looks nice. One thing that's kind of interesting to note is with the formatted input, it's going to keep trying to satisfy that read until it happens. So if I enter something like Bob again, I press enter, because this line of code right here is trying to read 2 strings in, it's going to keep trying to read until it gets another string. So then I could, do space, 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 dude, and that will actually finish that read as being Bob, dude. Again, no matter how much white space shows up in between. And then the line of text got screwed up because of the multiple new lines. But, Bob, man. And then it's automatically getting that new line of text. And so you might be like, oh, well, why is it getting this new line of text? It's because there's this leftover new line here from when I typed enter. So what I'd have to do is to consume that new line character. You can read any character, including white space characters, by using get. So I would do std : cin.get. And that's going to read that next line of character, so that will consume, hopefully, that new line character that happens to be there, assuming I don't type anything else after it. So, world, enter, blah, blah, do, blah, 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 blah. And then we're good, right? And it showed up. That little fix that I put in there right now would not work if I did something like this, like Bobman space enter. Oh, now it finishes, because this line of code right here just read a single character. What you would have to do would be to consume the rest of the input. So the easiest way of doing that, to make sure that we read the entire thing that comes later on, would be to do another get line here. We'll just read that into from cin into line, and then we'll press play. And so now I should be able to do, Bob space, 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 man, space, 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 lots of stuff that's very interesting, and it shows up. Any questions? Yeah. Why don't we use using namespace std all the time, so to avoid typing out std? We will talk about what the purpose of namespaces is in a little bit, but we still want to cover some more of the basic concepts first before we hit some of the advanced ones. The main reason that I don't use using namespace std is that it tends to be bad form to do it, even if it makes the examples a little bit shorter. The main reason for not doing that is I don't want to include all those symbols that are inside that namespace into my current namespace. Because if I happen to have something that was named exactly the same thing, like for example, if I changed hello, change it for me, please. Okay. Right click, refactor, signature. If we just change this guy to be string, and I had now been, if I had been using namespace std, this would now break, because we now have 2 symbols that are named string in the global namespace and string in the standard library, or the standard template library namespace. So that would cause issues. I don't generally use the using directives at all when I write, to help avoid name conflicts. And when you get to larger projects, especially projects that have other sub-projects in them, you will really appreciate namespaces. because without namespaces, if you happen to have a variable or a type that happened to be exactly the same as somebody else's variable or type in one of your subprojects, you would now be hosed, right? Because you'd have to go change all of your stuff to be able to continue using their stuff. But if they use namespaces and you use namespaces, great, they can have the exact same name and no problem. But again, we'll see examples of this later on. But any other questions about reading input? We will get to namespaces in a little bit. Don't worry about that right now. Questions about reading input? Yeah. It depends. So the question is, how do you convert an integer or a string into an integer? Is your question, how do I convert an integer entered by the user, or like they enter like input as a number and you want to convert it? Or is your question, I happen to just have another string somewhere sitting around that happens to be a number and I want to convert it? One or two. The user enters a number, or you just happen to have a string that represents a number? So if we're in option number 2 and we just happen to have a string that represented a number, and that was all that was in the string, the method that you could use is std : stoi, string to integer, or there's string to double or string to float as well. So if I happen to have some other string over here whose name was num, right, and it happened to be the string 123, and I could actually have an integer value is equal to std : string to integer, and we want to convert num, and that should be good. And now I could, std : cout, value equals value. And so now that will have converted that number, and it will display to the screen. Yeah, it's creating a copy. It's not modifying the original string, because the original string has to stay a string. It cannot become a number. But if we were asking the user to enter a number, say something like int age, again, just like an example, we could just cin into age, and it will convert it for us automatically because it came from a stream, and we know that we're reading into an integer. So now if we go ahead and run this, and we enter in something like 50, we'll be 51 years old next year. So it's actually an integer value now. And I didn't have to read it into a string and then convert it using std or string to integer. We will talk about, though, later on, like how we can verify that the input that the user has entered is valid, right? It's actually something that we intended, that they gave us what we intended to receive, right? Like if we're asking for an age and the user enters in something like Bob. So this is an interesting example. So let's say my age is equal to 99 by default. So some interesting things to enter. Let's say my name is Bob, right? And you can see that kind of everything just did not work. Well, so what's going to happen is Bob will fail to read. I'm not sure why age, let me just try again. I'm not sure if it rebuilt. Oh, it built. So it gets 1 as my age for whatever reason, but it will have failed to read the value and tried to update it to be that from the cin statement. So my age didn't update correctly, and that Bob should still be there. So when it asks for hello world, fail. Let's actually debug it and see what's happening. Down about here. So we enter in Bob. And so it looks like everything here has kind of failed because the stream is no longer good. Then we do a get line. You can see that none of our variables actually got initialized to be anything besides num, who had the value 123. And you can see that age got magically reset to 0 because of the failure to read. So a little bit different behavior than what I'm used to have happening. But we'll show you in a minute how to check to see whether the read was successful. So be careful with that. Did you guys do any input validation in your previous courses? Like making sure that the user actually entered what you wanted them to enter? Okay, we'll do the same thing here too, but it might look a little bit different. So moving on from input, we have if statements. So in Python, right, it's like if some expression colon do something, else if some other expression do something, right? Otherwise else do something else. In C++, it's if expression in parentheses, curly bracket to denote the code block. Else if expression 2, right? Curly bracket to denote what code belongs to that expression. Right? You can keep doing as many ifs, else ifs as you want to, finally terminated by an else. Again, just like in Python, else if and else are optional. You have as many else ifs as you want. The first one that's true, that's the one that you run. Questions here? Okay, that one should be pretty easy. You may have seen this expression in Python, a equals x if expression, otherwise y. The evaluation of this expression is x. A will be x if the expression holds true, otherwise it's going to be y. If you want to do that same thing in C++, your variable is equal to expression, question mark. If the expression evaluates to true, you'll get x. If it evaluates to be false, you'll get y. Any questions here? Okay, Boolean operators, so you have not, and or, just like in Python. But in C++, not is an exclamation point, and is 2 ampersands, and or is 2 of the pipe characters. The pipe character is your character right above enter on your keyboard. They had the same precedence in Python, not has highest precedence, followed by and, followed by or. If you need to change the order of precedence, right, use parentheses to make sure that what you want to have happen first happens first. Questions here? It also will do short-circuiting logic, right? So if you have some expression like A and B and C and D, if A evaluates to be false, right, the entire expression we know is going to be false because it's all ands. And C++, just like Python, will stop evaluating the expression there. So the first one that would be false in a series of ands, we will not run any of the expressions that come afterwards. Or if we have ors, A or B or C or D, right, and A evaluates to be true, we will not evaluate B, C, or D because we know the entire expression will evaluate to be true. While loops, so Python while expression, code you want to run, C++, while expression in parentheses, curly brackets, code that you want to run while that expression holds true. There is also a do while loop. This does not exist in Python, but exists in C. So you say do some code that you want to run while some condition holds true. It's more or less a while loop that always runs at least once because the condition is checked at the bottom instead of being checked at the top. So even if expression is bound to be false all the time, I do like while false, I will do this code here first, then check my expression, and I will not repeat it. So it's useful if you want to do something 1 or more times. Use the other one if you want it to happen 0 more times. For your range-based for loops in Python, right, you had like for I, in range, start, stop, step. More or less the equivalent in C++ is for you make some variable I equals start, I is less than stop, I plus equals step. Not quite a direct one-to-one translation because if step was negative, right, we would need to change our less than to be greater than, right? And our plus equals would still probably be the same thing, right? So if you're going backwards, you're going to have to change the direction of the sign to make sure that it happens correctly. Just a little bit more details on what happens here. The for loop is broken down into 4 sections: the initializer portion, the condition, the update, and the body. In the for loop, the initializer, the condition, and the update are separated by semicolons. The initializer portion is always going to be run regardless of the condition, and it gets run before everything else. It's only run that single time, and this is normally where you're going to set up your variables if you have any. You can declare variables there, but they all have to be of the same type. They can't be different types in that expression. If you need the value of the variable after the for loop completes, you have to declare the variable before the for loop. So if I needed the value of I back here after my curly bracket ends, I'd have to declare I up here, int I at this portion, to make sure that it still was in scope after the for loop finished. The condition is just like the while loop condition or whatever condition you want to hold true. It can be a less than, greater than, and it can be as complicated as you want it to be, or as simple as you need it to be. It'll be checked before the for loop is run. Then there's the update section. This will be ran after the body. This is normally where you put your portion of code to move you to the next iteration. The variables declared in the initializer section, update section, they don't have to be ints. They can be any variable types. You can do more than just plus plus or plus equals or minus equals. You can call functions there and assign to them and be as complex as you want it to be. Break and continue also exist in C++. Break will cause you to leave the current loop that you're inside, and continue will bring you to the next iteration. Do you guys remember what's the difference of using continue in a while loop versus using continue in a for loop in Python? Sort of, but not quite. So, right, with continue in both a for loop and a while loop, it'll bring you back to the top of the loop, right? But in Python, when you had the continue statement, not only did it move you to the top of the loop, it also advanced you to the next element, right, that you're iterating through. So in C++, you still have that same kind of behavior. If you have a while loop, it's going to kick you right back to the very top of your piece of to your loop, and you'll pick up execution from there. If you forgot to update, well, then now you're probably stuck in an infinite for loop. So watch out with that. If you have a continue statement in a for loop, it will run the update section and then bring you to the top of the for loop. So, move you to the next element and then bring you back to the top. So some new things, there's pre and post increments. There's like a plus plus variable and a variable plus plus. These are called the pre and post increment. Pre-increment will add 1 to the value first, and then we'll use this new updated value in the result of the expression, if there's any larger expression. The I++ will use the current value of I in the expression that you're evaluating, and then go and add 1 to I afterwards. It's super duper common to see them in range-based for loops. If you use them just by themselves, like you just have a line of code where it says plus plus I or I++, they're going to behave identically to you. The only time they start to look different is if you use them as part of a larger expression, which I do not recommend doing because it gets really confusing really fast, which I will show you an example of it getting really confusing really fast on the next slide. So on the left-hand side, we have the pre version. The right-hand side, we have the post version. The rest of the code is the same. So you make a equal to 5, then we do plus plus a. On the right-hand side, we do a plus plus. Because those lines of code are essentially by themselves, they're going to have the exact same effect. We'll add 1 to a on the left-hand side, make it 6, and then use that value as the result of the rest of the expression. There's no other part of this expression, so it just makes a 6. On the right-hand side, we use a in the rest of the expression, but there isn't one, so we don't really do anything. Then we add 1 to a so that we get 6. If you do something a little bit more complicated, like we do b equals plus plus a plus 4, well, first we add 1 to a, right? So a's value goes from 6 to 7. Then we do a plus 4, but again, A is now 7, so you're getting 7 plus 4 to be 11. So B ends up being 11, and A ends up being 7. But over here on the right-hand side, if we do A plus 4, well, first, we're going to use the current value of A to calculate the rest of this expression, which is 6. 6 plus 4 is 10, so B ends up being 10. Then you add 1 to A. So A ends up being 7. So in both situations, A ends up being 7, but the value of B ends up being different. And this looks confusing, right? So I recommend not doing it, right? If you're doing the pluses, just do them by themselves. And again, doing them in the update expression is considered doing them by themselves because that piece of code that expression is evaluated on its own. Any questions about for loops or pre and post increment? Yeah, you can. The plus equals operator still exists in C++. So if you want to increment by 5, I plus equals 5. Or if you don't like the plus equals operations, I equals I plus 5. Right? All of the updating operators still exist in C++. So plus equals, minus equals, times equals, divide equals, mod equals, they all exist, and you're free to use them. C++ does have element-based for loops, so you can say like for element and iterable do something. In C++, you have to say for element type, whatever its type happens to be, element name, whatever you want to give that variable name, in your iterable. But instead of writing the keyword in, it's like colon, and then you do your body. When you're doing these range-based for loops, or these element-based for loops, this is a really good place to use auto, as long as you know what the type of the variable is going to be, right? But you can also do some different things, like you can do auto-referenced, or const auto-reference. If you do auto, right, you're going to end up with a copy of whatever that element in the iterable happens to be. This is just like it is in Python, right? Over here, element is a copy, right? So if you change the copy, the original is not modified. Right? If we do something like this, like I have a list, L who's equal to 1, 2, 3, and I do something like for x in L, x plus equals 1, right? And I get back, well, L's still 1, 2, 3, right? I got copies of each of the elements that I then modified. If you just use auto, you are going to end up with the copies of the values just like in Python, which could be good or bad depending on what you wanted to do. If you wanted some copy to be able to change it later on, great, use auto. If you're only planning on reading the element, it's much better to use const auto reference. This way I don't actually have to copy the object, but I won't accidentally change it either, right? So if you're just reading through the elements in your iterable, const auto reference. If you want to be able to change the elements in the iterable, auto reference. This will allow you to go through the elements and update them. So if I did that plus equals in C++ with an auto reference, it would allow me to modify the elements inside the container, and the container would be changed afterwards. They just have a reference to those values. Again, you don't have to use auto here. If you had a string, instead of using auto, you could say, what's the type of an element in the string? Yeah, what's the type of each one of the things inside the string? A char, right? So instead of saying auto, you could say char. Or if you only wanted to be able to read the characters, const char reference. Or if you wanted to be able to change the elements in the string, auto char reference would work as well. But I tend to be in a habit of just having the compiler deduce the type of the element for me. Any questions here? Yeah. Like, why would I use auto? So, like, what does the auto keyword actually do? Is that the question? So the question is, like, what's the advantage of having the compiler deduce the type for me? I don't have to write the type. That's really the only advantage of using the auto, because sometimes the like types in C++ can be like 20, 30, 40 characters long, depending on what you get to. For example, we're going to see vectors in a little bit, which are basically C++'s equivalent of lists. So you might have like an std : vector of std : vector of std : string, right? And if I wanted to iterate through that, I don't want to type out std : vector of std : string reference to be able to modify it. Auto reference saves me so much more time. But again, only use like the auto keyword if you're like you understand what the type of the variable is that you're going to be getting back. Because if you use it in some situations, you might be surprised about what you get back. A lot of times the surprise comes from you have a function that returns a reference. So you say like, I have like an auto x equals this function, right? And that function returns like an integer reference. Auto gets deduced to be an integer reference. So you don't have a new copy of the value. And so if you go change x now, it changed the original wherever that came from, which could be a little bit confusing to figure out, where that error is coming from. Any other questions? Yeah. So the question is, in C++, can you have an array or a vector or whatever the Python list equivalent is where the elements are of different types? No. There are ways around it that use inheritance, which we'll get to later on, where you could have like arrays of parent pointers, and the parent pointers can point to their parents or point to their children, anybody that inherits from them. But no, you're fixed with a vector of integers or a vector of characters or a vector of strings. You can't have a vector of strings and characters and integers. It doesn't work. If you look in the Boost library, which is like a separate standalone library that has a lot of cool things, they do have support kind of for what you want. They have like a type called any, but where any could be like in any type. But it gets more complicated working with it because then you have to keep asking, well, what's the type of this thing? Well, what's the type of that thing? What's the type of this other thing? Because the interface isn't always uniform, right? A string is not going to end up being the same thing as an integer in terms of like how I interact with it. So there are issues there. Anything else before we move on? Okay, finally, there's iterator-based for loops. You'll see iterators showing up quite a bit because they're using the algorithm library, which has a lot of really useful things inside of it. So all of the containers in C++, at least the standard containers, have begin and end methods, which return an iterator to the beginning for begin, and for end, they return an iterator to one past the last element, whatever one past the last element happens to mean for that container. But end is always going to be out of bounds. It will never be something that actually is referring to a value. And so that you can see later on, if you want to be able to get the value that the iterator is currently on, use star. So never put a star in front of an iterator that's at end or beyond because it's out of bounds. It kind of is a generalization of this for loop, like for I equals 0, I less than len, do something with the element at I. The iterator is going to hold basically a reference sort of to the current element that it's on. So this for loop over here is going to become auto iter equals container.begin. Iter doesn't equal container.end, which should have some parentheses there. Plus iter. And then instead of working with the element at position I, you just do star iter to get whatever that value happens to be. This for loop is necessary sometimes, but a lot of times I prefer to use the element-based for loop if I just need to go through each of the elements. In addition to forward iterators, you can also get a constant iterators, cbegin and cn, that will only allow you to read the values. You won't be able to modify them. Reverse iterators that will go through the containers in reverse from end to the beginning, and const reversed iterators as well. But not all the containers are going to support the reverse iteration through them. Only some of them do. So here's an example of an iterator-based for loop. It attempts to take in a string and make all the characters in that string uppercase. You could also do this with the range-based for loop or the element-based for loop as well. So here I have upper in place. So for auto iter equals string.begin, which should have some parentheses there. It's not equal to the end of the string. Go to the next element. Star iter equals toUpper star iter. Just 1 second. ToUpper is in CC type. It has the methods ToUpper and ToLower, but ToUpper and ToLower only work on a single character. So if we want to write our own functions that we're able to modify the entire string, we have to write them ourselves and just apply ToUpper to each character. Notice also this function accepts a string reference. That's super important because I want to change the original string that was passed in. Right? If I had left off that ampersand, what would I end up getting? A copy, and I would end up changing the copy, and so the original would end up not being modified at all, and I would be pretty sad at the end of the day and maybe a little bit confused. This guy over here prints the string in reverse. So I make my string begin at const reversed begin. It's not equal to const reverse end plus iter and then see it out. So it'll print out the string backwards. And then over here in main, we're just running that code on hello. We print it in reverse. So it's OLLEH. We make it uppercase, so now everybody's uppercase. Then we print it out in reverse again, so it prints out the string once more. But since it's been uppercase, you're going to see all your characters in uppercase. Yeah.
Question. Arrows?
Arrow here?
No. The last.
Oh yeah, that's a typo that got in there. Are there any other questions? Okay, so we'll get to verifying input in a little bit, but as for right now, we'll actually do some examples and we'll write some C++ code. And what I want to do right now is the string class doesn't provide as nearly as many functions as the stuff in Python. So what I want us to do is to write some functions that will emulate those functions. So right, we maybe want to like make a string in all uppercase like we just did, right? Also do one in all lowercase. What other functions that are supported on Python strings that are missing that you might want to be able to do? Maybe like strip them, right? Remove the leading and trailing, some leading and trailing characters. What else? We might want to be able to split the string, but in order to do that, we probably need to talk about vectors a little bit first, right? So that we're able to have a vector of strings as our answer, right? A list of strings to give back. Anything else that we might want to be able to do? I think like the only other thing that's kind of similar is like a join. That's kind of sort of defined on list, but it's really technically defined on like list of strings sort of. We'll try writing that as well. We only have 5 minutes, so we're not going to get through everything though. Oh, if you want to repeat a string, yeah, we can do that. That's pretty easy actually. But we won't have it. It depends if we actually want to have a function just called molt, or if you actually want to be able to do times a number. They're both doable, but one requires a little bit more knowledge to be able to do, which is so I don't want to do that other method right now. So I'm going to show you a couple new things. The first thing over here is we're going to talk about your CMake list. This is what's going to compile your project together. So over here, this first line of code just says what's the minimum version of CMake you need in order for this project to be able to be built. For us, let's say it's 3.13. Normally, you put this as low as you needed it, as low as possible for it to work. But for us, don't worry about it. Just leave it whatever C-line puts in. The next instruction you'd have would be the project, which again, you can probably leave as whatever you want. This one's called more string functions. Then we're going to set our CXX standard. Anywhere you see CXX in CMake, CXX is C++. One other thing that you could also do over here, if you want to add it, you could say like languages CXX, which means this project is going to support C++. It just declares the project. Just declares the name of the project. Correct. Over here, this add executable is the line of code that's actually going to generate your executable. Its name is more string functions. It could be the same name as the project, or it can be a completely different name. Very common for it to be the same, but you can change it to be something else. Then you list out the source files that make up your project, which right now we only have main.cpp. If you ever get to the point where you're working with your project and it says this file is not a part of your project, right? It's probably because you don't have its name listed here. You mean like how do you like import something? Yeah. So there's two different notions of a library. So if something's like already on your computer, right, part of the standard library, we're just going to import or include it. So pound include string, pound include vector, pound include whatever the header file that you need, and it will automatically be compiled into your program for you. If you actually have like some separate library that you've like downloaded, there are commands which we'll get to later in CMake that say like target linked library, and then it will add in that library to you and build it as well, or link it into your project. One other command that I'm going to add down here, which I also recommend that you do, it's target compile options, and then you list the name of your executable. Then you would have private, which means it doesn't extend beyond more string functions, and dash wall and dash w error. Dash wall means turn on all warnings so that you'll be told about more things that are probably wrong with your code instead of them just being ignored and your code compiled anyway. And W error, which means to treat your warnings as errors. So if you do have any warnings, your code will refuse to compile, period. This will just help you catch more bugs as you're working through things. So add that into your code. Then once we're done changing things over here, we have to click reload changes, and it will update our project. And maybe a second time too. Next thing that I'm going to do is I'm going to make a new file to have our stuff in here. So I'm going to do new C++ source file. And I'm going to call it like more string functions. And I'm also going to create a header as well. This will create both of those two files. And notice that it also added both the CPP and the .h to my project. If I accidentally, if for whatever reason I didn't have this in here, and we reload the changes, if we go over here to more string functions, it says this file does not belong to any project. Target code insight features might not work properly. So if you ever get this error or this little warning appearing at the top of your file, it's because it's missing over here in the add executable line. If we pop it back in and we reload the changes, then it's happy. We'll talk more about header files and which are the .h files and the CPP files on Wednesday, and we'll actually start writing some code to get you a bit more familiar with C++.